Okay, 8.2 day 1, Intro to Graphing Rational Functions. The first thing we're going to talk about is just what is a rational function. So a rational function has a variable in the denominator. This is a very basic denominator, a very basic definition. It's not the technical definition, but just as a general rule to understand, we're looking at something where our input is in the denominator of a fraction. So it's going to act a little differently. So this is the parent function. It's just the function y equals 1 over x. So we're going to start by just graphing this and then talking about the general features of the graph. So if I have y equals 1 over x, actually I'm going to add -1/2 to my table. 0, +1/2, 1, and +2. So I'm just going to start with some values, plug them in, and see where that gets me, and then we'll graph them. So 1 over -2 is -1/2. 1 divided by -1 is -1. 1 divided by -1/2 ends up being -2. So you can see that what we're basically doing with this equation is finding the inverse of each of these numbers. 1 divided by 0 is undefined. So I'm just going to put a line there. It's important to note that point, but we don't have a point to graph at this time. Okay, and then 1 divided by 1/2 is 2, 1, and 1/2. Alright, so then if I were to draw my graph, my x and my y, so I have this point at -2, -1/2, and I have a point at -1, -1, and I have a point at -1/2, -2. And then I have this point over here at 1/2, 2, at 1, 1, and at 2, 1/2. So what ends up happening, if we were to continue this, we get this shape that goes like this. And if we think about, we know that we're not allowed to divide by 0. So this is an asymptote right here, and I'm gonna, because it's on the axis, I'm gonna just kind of dash it in like that so we can see it more clearly. So I'm never allowed to have x as my input. So this is my vertical asymptote right here. And then also there's no number that we can divide 1 by to get 0, right? 1 divided by 3 is 1/3, 1 divided by 100 is 1/100th, 1 divided by 1,000,000 is 1/1,000,000th. We're going to get smaller and smaller and smaller the bigger we get, or we're going to get smaller and smaller and smaller negative going this direction, but we're never quite going to reach 0. So we also have an asymptote here at y equals 0. Okay, The shape of this graph is called a hyperbola. I almost said hyperbole. Going back to when I used to teach English. No, it's a hyperbola. And it's just this general shape like this with two branches. Okay, so the whole graph is called a hyperbola. Each of these pieces of it is called a branch. For just our very basic inverse functions here, or sorry, inverse variation functions, the domain is always going to be x is all real numbers except 0. So I'm just going to write it like that for now. X cannot equal 0. And our range, y is all real numbers except 0. So y cannot equal 0. And so then we have a vertical asymptote at x equals 0, corresponding with that domain there, and we have a horizontal asymptote at y equals 0. So these are the general features. This is going to be true for, or this is going to be true, and the shape is going to be true for any function where it's just y equals 1 divided by a number. Or, sorry, y, oh my gosh, where it's y equals a number divided by x. What's going to happen is this part is going to pull out or closer into the origin, but the shape will stay the same and the asymptotes will stay the same. I will demonstrate this with another example. So what if we had y equals 4 divided by x? We have y equals 4 divided by x. Again, thinking about that table. Okay, so 4 divided by 0 can't happen, so we already know that that's the asymptote. Like we said, that's always going to be the case if it's just a number divided by x. 4 divided by -2 is -2. 4 divided by -1 is -4. 4 divided by -1/2 is -8. And then there's the symmetry here. This is going to be +8, +4, and +2. So when we graph it, not draw my graph very well here, but that's okay. I still am going to have the asymptotes in the same place. So I have y equals 0, and I have x equals 0 as my asymptotes. And it's always a good idea to just sketch those in and label them so we remember that they're there. And then I have a point at -2, -2, -1, -4, and -1/2, -8. So we can see that this one is pulled out further and it stretches a lot faster. Here I have a point at 1/2, +8. I have a point at 1, 4, and I have a point at 2, 2. Oops, I missed Okay, something like that. It's kind of awkward for me to draw with the phone and the cables and everything in the way, but you can kind of get the idea of the shape. Okay, so again, my domain, all real numbers except 0, so x is not equal to 0. My range, all real numbers except 0, so y is not equal to 0. We have our asymptotes labeled. We can see generally the shape of it. There we go.